Hello everybody. Following on from our last discussion of what's happening in cutting-edge astrophysics, today I want to discuss another topic that is currently occupying a large amount of research time, and the reason this topic today I think is so fascinating is this is a genuinely unsolved mystery in astrophysics, and you've got a lot of physicists across the world working to try and crack this mystery, and just over the last few weeks some progress was made. So what is the mystery? The mystery concerns something called fast radio bursts, or FRBs. What are FRBs? Well, they are point-like flashes in the sky of immense energy for only a few milliseconds. They were first discovered in 2001, a burst of just a few milliseconds, but with the energy of 500 million suns. Let's think about that figure for a minute. That is a huge amount of energy being emitted from a point source. Of course, back in those days there was a concern that perhaps there was a problem with the equipment. Often when you see these flashes in radio telescopes and telescopes in general, you kind of doubt whether it's an equipment origin or an astrophysical origin. But subsequently, many of these point-like FRBs have been detected in the sky, and they are accepted as a genuine physical phenomenon that must be explained. So to begin with in our explanation, let's try and think of what it could be, and then we can try and narrow down the results from what fits the actual experimental observed profile. The first piece of information that's extremely important is the length of the burst. As I said, the length of an FRB is only a few milliseconds, and this actually places some kind of boundary on the size of the object that could cause it. For a ordered millisecond burst like this, in order for all elements of it to be in causal contact over this timescale, the fastest piece of information that can travel is at the speed of light. So if you multiply this time by the speed of light, you actually get an object size that can only be a few hundred or maybe thousands of kilometers in size. In astrophysical terms, this is very small. The second interesting piece of information is that, while originally they were thought to be just point blasts that did not repeat, subsequent measurements, and indeed at the paper I'm going to reference today, which is appearing on the screen now, the CHIME report, which is a Canadian telescope, they've actually discovered that there are two sets, or two types of FRBs. One that appears to just be a single event, a single flash in the sky, and others that appear to repeat on relatively long timescales. So there are two categories of this event. Two categories probably means two separate physical generation mechanisms, one for the discrete blasts and another for the continuous pulsing, if you will. So you remember there are two types of fast radio burst. One is repeating and the other is not. These have two different astrophysical phenomena. Let's deal with the repeating version first. These are actually probably quite difficult to explain because there are not that many processes in astrophysics that cause repeating events. Clearly one of the most common or most obvious is some kind of orbit. For an orbit, what can we have that produces a burst of this magnitude or radiation of this magnitude? Well, the current theory is the possibility of a neutron star orbiting another star. Well, let's take a step back a minute and see why this might cause a burst of radiation. A neutron star is the remnant of supernova. Now these are actually very complicated topics, very interesting and unusual objects, and I'll cover them in more detail in a video that I'll release next week. But for the time being, all you need to know is they're extremely dense, very small in astrophysical terms, remnants of supernova explosions, in other words dead stars, that have immensely powerful magnetic field, billions, trillions times that of our sun. They are powerful magnetic objects. From an ordinary star, at the same time, you have a phenomenon called a solar wind. A solar wind is a wind or an ejection of materials that contains charged particles like electrons, protons, and other non-charged particles, atoms, and so on and so forth. In the sun, the solar wind is caused by the immense heat at the surface, the corona, heating particles up to a sufficient temperature to escape the sun's gravitational field. Now, not a lot of material is lost from the sun in this way, but it's enough. Now, if you have done any form of classical physics, Maxwell's equations, or electromagnetism, you will know that as charged particles like protons and electrons move through a magnetic field, they are accelerated or bent, they form an arced path. As they are accelerated, they emit radiation. So what the theory is for these types of periodic fast radio bursts is, as a neutron star which highly magnetized orbits another ordinary star, that solar wind is interacting with the huge, immense magnetic field of that neutron star. Those particles, as they're accelerating that magnetic field, will release radiation, and that's the radiation we see on Earth. It's periodic and point-like simply because the orientation or the orbit will only be in our line of sight on a certain number of occasions and not continuously. And so then we have the second type of FRB, and that's the non-repeating FRBs. Now what could these be? Well, clearly these must be one-off events. Well, what can a one-off event be in astrophysics? Well, most people think of things like collisions. So some of the theories have been that colliding neutron stars will release a huge amount of energy in a single burst. Other theories include magnetic storms on special types of neutron stars called magnetars. A magnetar is a neutron star with a particularly strong magnetic field, maybe 1,000 times more than an ordinary neutron star. So we're really talking very strong magnetic properties in that case. In other words, we don't really know what causes them. There are many possible theories and explanations. And maybe there are multiple explanations and not just one. And that really brings me to the conclusion of this video. What you're seeing here is the absolute cutting edge of astrophysics. This is what people are currently engaged in, and people do not know what causes these fast radio bursts definitively. There are many current theories, but no clear winner. And there's not a sufficient data set, or at least there wasn't until recently, in order to test them thoroughly. So to give my own perspective, obviously it's exciting to deal with these completely unexplained astrophysical phenomena. From my perspective, it's even more exciting that they are possibly created by some of the weirdest objects in the universe, the neutron star. But most of all, what I find interesting about this is the current debate over the theoretical mechanisms. There's something about it at the minute that's very untidy, and the untidiness doesn't appeal to a physicist or a scientist. Usually, we want one single explanation that brings everything together in a fundamental physical process. Currently, what we've got is multiple types, repeating and non-repeating, and multiple theories, none of which are completely definitive. In other words, the landscape currently is very messy from a theoretical perspective. One would hope, and in order to create the big advances in science, you manage to boil down this complexity to one or at most two simple physical processes that can explain the experimental results. However, for that progress to be made, we are still waiting. And for those of you who are currently at school or embarking on your own university studies, maybe the person to crack it could be you.